In ionic compound, one positive ion, another one is negative ion, right? Okay, and this positive ion is called what? Cation, and the negative ion is called what? Anion. And in general, we have a notion, we think somebody has told us that these ions in the compound, they are what? Spherical in nature. But this is not always the case, right? So when you go detailed with ionic lattice, we came to know that inside ionic compound, if it is cation and if it is anion, so because of this, what is this? Cation, the structure of anion is slightly distorted. Can you see? Which was supposed to be spherical. So, and in general, always remember, the positive ion is smaller in size. Always, if you take any ionic compound, and the negative one will be bigger in size. Why? We'll come to the end of this topic, right? So, it should be spherical in nature because, because of electron cloud. In fact, this is spherical because of electron cloud. It should be spherical, but because of this cation, which is disturbed. Cation is disturbed or anion is disturbed? Anion is disturbed, and we call this is distortion of electron cloud of what? Anion. And this distortion we call in our chemistry language, we call what is?
Ion polarization.
Ion polarization. Got clear idea? So the ion is polarized. And can you remember in chemical bonding, have you heard about polarization? Yes, the electron, the shared pair of electrons slightly shifted towards either cation or anion, because in covalent bond there is no cation, no anion. So but slightly it was shifted, then we can see what? Slightly what? Ionic character. But here, once again I'm telling, any questions so far? What is the ion polarization?
It is the changing of the shape of the distortion of the anion.
Distortion of electron cloud of an anion due to or because of cation. The attraction of cation is known as what? Ion polarization. But nobody will ask you the definition. You should know the concept, right? So when there is a distortion, you will notice, since it is ionic compound, but inside ionic compound we will find some covalent character. And you have already studied about ionic bond and covalent bond. And if you find the covalent character in ionic compound, what are the special characteristics? Can you tell me what are the changes you will notice? It is purely ionic, and if it is, if you find slightly covalent character in covalent character in ionic compound, what are the slight changes we will get? Can you imagine what may be the cause? There will be change in boiling point. Who has more boiling point and melting point? Ionic compound?
The ionic compound has a higher.
Yeah, they have more melting point and more boiling point. But if we find a slight covalent character, then definitely their melting point and boiling point will be affected. This is case one. And second case, what will the second case? Yeah, what are the changes? Solubility. Who is strongly soluble? Ionic compound or covalent compound? Ionic is very good means very good what? Solute. But if you find covalent character, their solubility will decrease or increase. In an ionic compound, if you find covalent character, what will be their solubility character? Decreased, because ionic compounds are very good solute. But if you find covalent character in them, so then their solubility will decrease. Next, color. So generally if it is ion, that will be what? Crystal structure, transparent. But if you find covalent character, their color structure will be affected. These are the few characteristics. So we'll discuss one by one. Now if I ask you why it happens, what is the cause? Why we can see this type of spherical structure is affected by this cation, and we call what is a distortion of electron cloud. Why it happens? Why? What may be the cause? What may be the cause? What do you think? Yes, this cations, which is positively charged, and this is what? Anion, which has more number of electrons, right? So they have more number of electrons, so we call it as electron cloud. So in fact it should be spherical, since this ion will attract the electrons towards it. So that is why what will happen? The shape, the spherical shape will be distorted. So then we can see this type of structure, right? And what are the factors affecting in this ion polarization? Who are responsible for this ion polarization?
The electrons.
Yeah. And one thing to remember, who is polarizing? Who is polarized? Anion is polarized and cation is polarizing. Okay. And this entire ion polarization depends upon both, but more is what? because it is distorted. The electron cloud is distorted by what? Cation. So that is why the power of cation, this is not polarizing power of the cation. This ion polarization. Ion polarization is what? Depending upon cation, that is called polarizing power of cation. So cation is polarizing and anion is polarized, right? Now what are the factors affecting? Look here, there are many factors. Number one will be, what will be the number one? The size of, first I will tell about cation. First I am going to tell about the effect of cation, then I will tell you about the effect of anion. Okay, so first is size. First one is size. Look here, I am telling you some size. Suppose this is one cation, this is one cation, and this is one cation. Okay, this is case 1. This is also cation, this is cation, and this is cation. Who will have stronger attracting power because they will attract electrons? This one or this one or this one. It has bigger size, it has smaller compared to this, and this is the smallest in these 3 cases. Who can, because you know this distortion happens because of the attraction of electrons towards what? Cation. So who can attract, who will have more attraction power for the electrons? Can you tell me in these 3 cases? The biggest one or the smallest one? Look here, if it is becoming smaller in size, more positive charges will be concentrated. If this is more concentrated, then they will have more attraction power. Okay, if the size of cation is smaller, they will have more what? Polarizing power, because they can distort what? The electron cloud of anion. So that is why bigger the size, smaller the polarizing power, or smaller the size, greater the polarizing power. Okay. Next case is charge. Next case will be charge. Now if you take same size, okay, suppose I am taking 3 cation of same size, but this has, if they have more number of proton or more number of charge, they can attract more electrons and they can make it more distortion, right? So that is why if the charge increases, the charge of cation increases, they will have what? More polarizing power. Any question? No. Next question. Again, in fact, these are the 2 factors given about cation in your textbook. But another one, number 3, I am going to tell you, though it is not given, but if you know, it will be good for you. Do you know noble gas configuration? Do you have any idea about noble gas configuration?
The shells are all.
Yes. Any idea about noble gas configuration? So if I write NS2, NP6 or ND10, so generally these are the noble gas configuration, stable configuration. If any ion they possess this noble gas configuration, they will have more polarizing power. Okay, for example, can you tell me the Can you tell me the electronic configuration of copper? What is the atomic number of copper? Atomic number of copper 29. So atomic number is 29. If I write its electronic configuration, can you help me please? 1s2, 2s2, 2p6, 3s2, 3p6. But instead of writing 3d, then we will write 4s1, 3d10. Am I right?
Yes.
Can you remember all this electronic configuration? Okay, can you count 2, 2, 4, 6, 10, 11, 12, 12 plus 6, 18, 18, 19, 19 plus 10, 29. Yes, it's right. Right. So this 4s1 is what? Outermost electron. Since this is outermost electron, when copper is becoming copper ion, so then what you will get? You will get the electronic configuration 3s2, 3p6 and 3d10, which is what? Stable configuration. So then the copper will have more ionizing power. Are you getting the point?
Yes.
So anyway, basically we are given importance size and charge. If they have smaller size, they will have more ionizing power because they can attract, because more concentration of charges. And similarly, if the cation has more charge, they will have more polarizing power. So these are the 2 characters about cation. Now let us go to discuss about anion. Any questions so far?
No.
If I talk about anion, so basically anions are what? Bigger in size. Look here. If they have bigger in size, their nucleus will be what? At the center. So the nucleus cannot hold the electrons very tightly. So then it will be easy for the electrons to be what? Distorted. So that is if the size is bigger, the distortion also will be higher, right? And so first case is what? Size. How the size is affecting for anion. If the size is bigger, there will be what? More polarizing power for the cation. Next, when it is coming for number of electrons. If there is more number of electrons, the nucleus cannot hold. If it cannot hold the electrons easily, they will be distorted. So that is why it also depends upon what? Number of electrons. These are the two factors about what? Anion. So now for ion polarization, we came to know about ion polarization, and what are the factors affecting? It is the what is called combination effect of both cation and anion, and whose role is what we discussed very clearly. Any question, right? So if you see, it's very clearly written the factors affecting ion polarization, right? So the thing I discussed here is written here. Anion is more likely to be polarized if they have 1, 2, 3, 4 characters, and the degree of polarization of anion depends upon density and so. And okay, this is the 2 characters given here. Any question? No question. So then I have the questions. So you have to answer these questions, right? You have to answer the questions and you will tell me if you have any doubt. Now, we have one more concept, or do you want to do the question? We'll move with concept. Okay, look here. Enthalpy change in solution. So when an ionic solid dissolves in water, what happens? The crystal lattice breaks up and the ions are separated. When an ionic compound, if the ions are separated, some energy is required. Okay, for example, if I tell you about magnesium chloride, in magnesium chloride, what happened? Look here, in this case. So during the formation of sodium chloride, from sodium ion and chlorine ion, how much energy is required?
Minus
787 kilojoule per mole lattice energy is released. During when this much amount of energy is released, then this ionic compound is formed for 1 mole of sodium chloride. So then when you want to separate them, you must give this amount of energy. Consider you will take a container. In this container you will take water, then you will add 1 mole of sodium chloride. But if you want to separate 1 mole of sodium chloride, we have to supply this amount of energy in order to separate 1 mole of sodium chloride. But we notice that we only supply 3.9